Hello, and welcome all to the Women Who Code podcast. And the topic for today's discussion is RPA, machine learning, artificial intelligence, and automation, process automation in general. Uh, I am Preeti Thukaram. I have about 15 years of experience in software. I started as a developer, basically as a C# developer. I'm an engineer. I have a degree in electronics and communication, but I started my first career in software development, and I have been progressing roles from a developer into a program analyst, a program management, product management, and so on. I moved into the RPA and automation space around 2015-16, when there were the initial conversations around automation and how we can improve the work culture of people and business processes in general. Since then, I've been associated with automation and it has progressed. Today, we have a lot of AI and ML, which I will be speaking to you as we progress into the call. And I am the associate director in a company called Invenics Services Limited. And Invenics Limited, the headquarters is in UK. We have offshore centers in Canada, India, and other places. I head the service line for automation here with a number of excellent people. We have teams of developments and sales who report to me. So diving directly into the topic. So basically, I will start with, introducing what is automation. So the story of automation, we call it. So where this begins is all of us are aware that there was this assembly line, kind of work that was there. People used to fill cans, cans of fish, cans of beans, long ago. This was an assembly line infrastructure where people used to work like machines. But this was replaced shortly by robots, physical robots. You had robots, you would have seen pictures of robots, filling cans and filling, cakes and creams and such. So what this meant to the physical world that day was they improved on the time. Robots could do work much faster than human beings. It could do it more accurately. It could do it overnight. There was no need for sick leave, or there was no, people fainting on the jobs and creating a break in the assembly line. So efficiency was improved. So this was what brought about the robots and how physical automation came up. This people are familiar with. But this led to the discussion about how we can do business process automation as well. The reason for this are many. There are many reasons. One primary reason that brought about this innovation and this thought process was there were a lot of clerks and people in the data entry sector who were basically not using their intelligence. What they would do is read data and type in data. Without using any human intelligence. Basically, they were doing a robotic work. They were working as robots. So they would read data from invoices, they would read data from Excel files, they would read data from, other systems, probably other interfaces, whatever they be. They had no idea what this data represented. There used to be huge volumes of such data, records spanning thousands of, rows. They would just read it and type it. Come in the morning, 8 o'clock, leave out at 5, and throughout the day you type in data from one interface, maybe paper, maybe another system, maybe an image file from somewhere. They used to type this data. What this meant is low quality of work for the person who was doing this job. And when you continuously keep doing this kind of mundane job, you introduce human errors. Human beings have an attention span of about only 15 minutes or 20 minutes. After that, you lose your attention span, you lose your efficiency, you lose your focus. So instead of reading from the 10th row, they'll be reading from the 11th row, and there will be a cumulative error that has been introduced. So this later will be identified by a supervisor or a manager. They will come back and do all the re-entry. They will have to delete these processes. Again, there's a lot of overhead. So low quality of work, tedious work, low efficiency of work because of introduction of manual errors, and high risks. Sometimes if this data, for example, let's imagine that this data represented the mark scores of a few candidates for an exam, and they were entering it into the result system. So if they were entering data scores for candidates, and if this person, after entering hundreds of students, on the 200th student, if they just made a mistake, it meant that you were entering marks that were scored by another candidate. And this could mean a lot of, changes, risks, and errors. And if not noticed, this could also mean a huge loss for the real business user, that is the candidate himself, where he would have received scores which did not mean for him. Sometimes errors are caught, sometimes they cannot even be caught. So given all these kind of issues and the cost involved in, repairing these issues when they occur, uh, was so huge, and the inefficiency and the not being able to identify these issues were so huge, that we thought automation could be a solution where machines can be made to work like machines and humans can use their intelligence for validating, approving, escalations. Probably the robot could not, do a particular entry. Then a human being would step in. That would be an escalation. Probably a robot needs a judgment. He cannot make out if the score is 25 or 55. Probably the numbers look very similar. That's when a human needs to step in because his intelligence is required there. So probably there is some, kind of infrastructure issue where a human being needs to step in. So these are the various areas where a human being could step in. Otherwise, he could take a step back and the robot, the programs themselves can do a lot of work. This is how automation was envisioned way back a few years ago. And once they envisioned this, they started it off in a very low scale, and they started by doing small programs where they could read information. So this is the story of automation. The main aim of this was to improve the quality of work, to improve efficiency, to reduce risks, and to reduce cost, basically to add value to work and make it more interesting to human beings. So this was the story of automation. Now, going into RPA. So the RPA stands for Robotic Process Automation. What this means is, I mentioned physical robots, right? But these are not physical robots. These are software robots. Essentially, they're software programs written in a particular software. There are a number of vendors today out in the market. If you just do a Google search, you'll get a lot of vendors out there who are, releasing softwares for RPA. Most of them offer a free academy, which is the learning center where most of the women or men who are watching this program can go and register themselves for free. There are courses offered at a beginner level, advanced level, intermediate level, where you can, go through the courses. They're free of cost. You can train yourselves, build these programs, see what they can do for you. And if you're really interested, you can continue on to the advanced courses, like I said. Most of the software vendors offer the similar features with a little bit of differences here and there. What they allow you to do is to build a software program called as a robot. This software program will run on a machine and it will do the task that a human being would do. So a robotic process automation means building a software program that emulates the behavior of a human being in interacting with systems. So that's the definition. And what this means is, for example, I'm going to do login and I'm going to create login to a particular website, create go and enter some forms. Some personal details are there associated with myself. Once my profile is created, I'm going to go and read some information and collect some data. Now, this would be a task that I would have to do. And if I were to, given my profile, I need to do this every day. For example, if I am in Forex, I'm in a bank and I need to see the Forex rates every day. Every day the rates changes based on the markets, the equities. So what this means is I need to come in every day and log into this equity screen and then go and look at the chart, the current rate on that day, the Forex rate. And then I'll have to copy that down and then probably continue with my task. Now, this is a task that is repetitive, which has to be done every day. It is rule-based. What I mean by rule-based is I always log into the same website. I always use my same credentials to log in. I always access the same, probably the currency and find the Forex rate for that. I always download it into the same location, most probably a similar location with a date, which the folder might have or the file might have a different date. So still it's rule-based. So it's rule-based. It's repetitive and it takes time and it's totally inefficient. Every day morning, I can come in, I can, add value to my job by talking to my, colleagues and create a relationship or call my customer and have a, morning greeting while my robot can do this. So I can create a software program that can log in on my behalf, can access the website, download the currency rate, save it in my file. And then, once it's done, I can start my daily job. And it will take 1/3. There is a small study done. It can do it faster, but most of the business processes, depending on its complexity, if it's medium complex, it takes 1/3 of the time that I would take as a human being. So it is going to do it very fast and it's going to do it very accurately. It's not going to make any mistakes. Sometimes, in the morning, if I'm woozy, I'm going to enter some wrong credentials, go to the wrong website. None of that is going to happen. It's going to be hugely, efficient, quick, and efficient. So this, I could also schedule it. So which means every day at 9 o'clock when I log in, the robot runs and it does this job for me. This is a simple task. So what is the difference between a normal program and an RPA? The difference between a normal program and an RPA is a normal program works like software. That is, two softwares communicate between themselves as programs, right? So they will pass some parameters, they will require some data, they will, communicate through APIs. Probably they do this. But what RPA does is it will interact with the system like how a human being would do. What I mean is it will go and click the way I would click. So it takes control of my keyboard, it takes control of my mouse, or any of the interactive systems that I'm using. It will go via the same graphical user interfaces, GUI, that a human being would need to interact with the systems. And then it will enter the data the similar way. It will capture the data in a similar way as a human being would do. What this means is, this is called as cognitive automation. You would have heard the terms. What this means is, we use the term, we technology called as computer vision. So there are certain things like many of you would know what an OMR is, an optical image reading. Then there's an OCR, which is optical character reading. So what these technologies mean is the software robots will use these technologies to read the characters, to read the images as a human being would read it. So if there is text on the web page or a text on a particular system, it will read it, recognize it like how a human being would do it, and then analyze the data the way you've written it in the program, and then it will use it the way you interact. So it uses a technology, these kind of technologies for cognitive automation. This is the first simple use case where you can have a robot do the action of a human being, emulating the human being's interaction with the user interface. There could be another example for an RPA, for a robotic process automation. Now, this process, let me explain the process first. So probably you're visiting number of websites, right? And you're making a comparison. You're buying a mobile phone. So you would like to know how many mobile phones are available in the market. What are the prices of these mobile phones? Then eBay is offering a particular offer maybe for a used phone, or Amazon is having a package where if you buy a phone within a particular day, you're going to get a discount. And then there's probably another website somewhere who's offering you two phones for the price of one. So you would like to make a comparison across these various offers in the market. You would like to make a comparison of the features against the price. You would like to know if this phone is available in your region, if it's available in the color you want, in the specs you want, and how quickly the delivery will happen. Is it a door-to-door delivery? Do you have to pick up? So where is all this information present? It is present on the websites. On each individual website, there are probably you're looking at 3 or 4. Let's limit our business case. There are hundreds of websites today offering these services, but probably you're in a region and you're looking at 5 websites. 5 websites, if you go and put the search for a mobile phone of a particular model and a spec or a cost budget or a range, you're going to get at least 100 searches. Okay, so 1 web page having 100 search list, 5 pages like this, so 500. That many rows of data you have minimum. And it's going to be presented in varied fashion. No 2 websites will offer you in a similar format. There might be similarities, like they all offer it, but the way they presented the price may be in, a particular currency, some of them in US dollars, some of them in GBP, some of them in some other local currency, some of them will have VAT added, not VAT added, then some have images of their phone, some have videos of their phone, embedded along with it. Then the offers, the discounts, they're all different for different websites. Now it's going to be very, very tedious for you to go through these individual images and individual rows to assess the data. It's going to be very tedious. If this was for a company, as an individual, it's going to be tedious, and at some point you will take a call. But if this was for a company, a particular person will be associated to do this task. If you're buying this company, this phone for the company, a person will be associated. This person would probably, type down all this information from various websites into an Excel sheet. And then, he will do a sort on that Excel sheet based on the price or based on the, discount or something. And then he will present it to the procurement, the supply chain, whoever it is, to say that this is the best few phones that come up on the top after the analysis. And then please go ahead and make an approval. Now, this person would have spent about 8 hours, probably a day, to do this. 5 pages, 500 rows. He has to type into it. He has to sort it out and present it. He will take a day to do this. Now, an RPA can do it in 20 minutes or probably in 15 minutes or even lesser if the program is written in a very efficient manner, in a very optimized manner. You can do it even faster. What this means is once you create, you train the robot, right? You don't do a lot of work. You just train the robot by giving it the various websites and you run the robot. The robot will go and access, when I say robot, it's a software program. It will go and access these websites on your computer. The runtime is on your computer, so it's going to access this on a desktop. It's going to do something called as data scraping. You must have heard of this terminology. So it will scrape the data. As the word suggests, it will, cut the data. Basically, it's called scraping. It cuts the data out of the, kind of copies the data as is on the GUI, and then it will download it. It can download it into an Excel file. You can direct it to download it to a CSV file, into a text file, in a database. Wherever you want to place the data, you can place the data. This will happen within probably 10 minutes or 15 minutes of your time, sorted, cleaned, placed in a particular nice structured columns and rows manner, which is human readable. And then you have everything you want. So data scraping, it gives you a lot of options. Today, most of the software programs, have data scraping. The AIs have data scraping involved with that, because what they do is they kind of scrape data from different systems. Sometimes you need information, bits and pieces of information from various websites. You're going to apply to, you're planning a travel trip maybe. Then you need to know about the ticketing information available from a web, an airplane website. You need a hotel's information from a hotel's website. You need to know the things that sightseeing from some other, lonely planet or somewhere whose trip advisor who's telling you which are the best locations that you need to see. So different websites have different pieces of information. So what you could do is create the robot, direct them to these websites, collect all these different snippets of information, put them out into a single file, have a look at it, one single vision and call it, make a human judgment. That is where your time is spent. Your time is not spent collecting this data and organizing it. As a human being, your time is required to make the judgment. Let's look at the presented information in a structured manner and then make a decision. So this is data scraping and how that would help you to improve your quality of work, your quality of life in general. Then there is another, very interesting use case. I spoke about UI automation. What is UI automation? Is like I said, in the case of data entry, in the case of, education sector, you have students joining every year. You want to enter their entire personal details into the data system, the student network. You want the syllabus to be entered. You need to assign coursework to these particular students. You can create the robot. It will make the data entry by reading their, individual applications. It will make the data entry, then it will create their setup, their student login. It will email to them the entire end-to-end automation. Once the student submits his application, you can read the personal details. The robot will enter it into the system, create his login, create his, assign his syllabus, and send out an email along, with a copy to his teachers at his head of the department. So this is done. It's already in production in many of the, places around. You'll be seeing it happen in real-time scenarios. And this is done within a data protection environment. The cloud, wherever it runs, is protected. There is, it is a secure environment. It can be authorized. The robot will have access to only the data present in that particular environment. It cannot access data from elsewhere. You can, restrict the robot. It's not that once you run the robot, you train it, it's going to, access data from everywhere. That's not the case. You have the full, rights, rules, authorization, authentication, where you can, set everything up so that the robot runs in a secure manner, in a secure environment, and accesses data as action policies. So that's done. There is also very interesting areas that RPA is used these days. Some of you might have looked at it, and that is communications mining. So what is communication mining is you have huge communications happening, right? On emails, on chat channels, on social media is where people are communicating. So when people are communicating, they're trying to actually say something. There are so many things associated in your communication. You have greetings, then you have some requests, then you have some, you start with a context. Probably you have two different topics in a single mail where you say, having said that, I'm going to speak about another topic. So in a single mail, you would have spoken about a leave request, probably you would have also spoken about the project. A human being can do this kind of demarcation, can read between the data and such. These days we have AI embedded into that so that it can understand from the nuances of the communication that we do, what is being said, how it is being said, to whom it is being said. Is it being addressed to the sender? Is it from the sender? Is it being meant to the addressee, or is it just a news item and a reference point? Is it not something that an action needs to be taken upon? These kind of intelligence can be built into the robot, and communication sectors and communication mining is very important because we don't need to spend hours reading through emails. Once you set up this robot, it can, if an action has to be taken, it will pull that out and tell you. Parts of it can already be seen in, if you're using Office 365, or if you're using any of your tools, you will be seeing, the applications these days are giving you some information, some intelligence saying, this is something, your task is pending. Do you want to complete it? How they do it is they mine the data that, and they go through that huge volumes of data to identify the action items inside that. Similarly, more interesting aspect of the companies, organizations in general, large organizations, is process mining. So what is happening in process mining is any organization, whatever sector it be, will have a huge business process. When you say a huge business process, it will start somewhere. Probably they'll have a supply chain, they'll have to procure some materials, then they make some product out of it, then they have to market this product, then they'll have to sell this product. And after they sell this product, they have to, get a revenue, they'll have a purchase order, then they'll have a sales order associated with the sales part, then they'll have to reconcile the two, and they'll have to see if they make a profit. Generally, this is the trend. It may vary in bits and pieces depending on the sector. If it's software sectors, it's slightly different. If it's manufacturing, it's slightly different. But overall, the process spans across departments. What we mean is it spans. There is an inventory list where they know what all they hold. Then there is a procurement channel, how many suppliers you have and from whom you buy. And then there is a marketing department, how you market this product. And then there's a sales department, how it does the selling. And then in between, you have the whole manufacturing unit, if it is a physical product, or if it's a software services like my company, we have a development teams, we have deployment teams who create these solutions and who deploy them. This many number of teams need to work in tandem to get this, every month over the course of the financial year, all the teams have to work in collaboration with each other. Now they're doing so, but the way they do it is per department. Probably this first department has an Excel sheet and they're holding all their data about the suppliers in an Excel sheet. The second department is a little bit clever. They're using a database and they're having all their information in a database. Third department does not use an Excel sheet or a database. They have, kind of word to mouth probably. Everything is communicated by phone or chat or elsewhere. So data is used. Data is there, but it is used in silos. So they use it in a department in a silo. And they use it in different formats, in different applications, in different ways. As a result of this, what happens is most of them will be using the same data, but since they are not passing it in a consistent manner, in a structured manner, you will have to redo that work. So if they are presenting it in an Excel file and you can't use that in your application, you'll have to retype it into this application. You are presenting it in a database and those people cannot use it, then they'll have to convert it by using some other program. So there is a lot of inefficiency, work, a lot of redo of work that is done, time waste, data is lost in the process, or data is misread in this process. So to remove this efficiency, what we do is we install a robot that does process mining. What it does is understands the process that runs in this particular organization. It finds better pathways, better routes, more efficient routes to achieve the same end goal. So a single supplier, department can send supplier informations to the suppliers, probably to the management, probably to the marketing, probably to the development, the assembly line people. So different people, a single communication can be sent. How this can be identified is by using these robots to know where the loopholes exist, where the blockers are, and ease up the channel and create a better, the shortest path mechanism, we call it the most efficient path. So process mining, especially for large organizations, a number of departments are there. That will be the, it's being used today and just showing a lot of efficiency, reduction in cost, and reduction of risks, and improve efficiency, and stop people doing tedious work, repetitive, manual, tedious work. So basically, I have given you a lot of information about what is RPA, where it can be used, the different business use cases, etc. And I've also mentioned some of the tools and technologies available in the market that you can Google out, and there's free resources everywhere. So you can use all of them to learn. What you need is basically, of course, you need to have a course plan and a program where you can go through and learn. It's available in many. If you just go and Google, you'll find a lot of information on the internet. But apart from that, just some basics. What you need is you need an like any software that you build, you need an environment, development environment. It's called an IDE, where you can go and type in this code. These days, there is a low-code version for almost all RPA softwares have this low-code version where you can drag and drop the activities. You don't need to write code. Previously, until about a year or and a half ago, you had to write the code, but these days low code is so much in place that you can just drag and drop these activities, and you can read an Excel file, an activity to read an Excel file, an activity to convert an Excel file into a PPT, an activity to send an email. So they're all just activities. Drag and drop these activities, just show them where to whom to send the mail, or to which file to be converted into PPT, how many slides you want to convert this PPT into. Just indicate those simple parameters, and it will create it for you. So you need an IDE. It has a low code option. Anybody who has very little coding experience, who's not from a technical background, who's not from a computer science background, who has not done any web development, can start using this. If you are a business developer, if you're a small and medium enterprise, if you're doing your own accounting, you can start doing this kind of robot creation. If you're into media, social media, you want to collect information from various websites, you can create this using a simple low code solution. For people who are a little more interested and who have a little more expertise in using applications, you can run different robots, and you can make these robots interact with them.